start while others join. Okay. So good evening, good afternoon, everyone again. See, I think like last class we have a good introduction of ourselves, what each one of us are doing, a brief introduction of what where we are standing and why we have taken this course, and a orientation of the program, entire program, right? Like what it covers and why we need this course and how can we expert this course and who can take up this course and what is the background required, right? What is the educational background? What is the domain expertise, right? And
Hello.
what are the
Hey guys,
what?
I'm
Yeah, Manish?
I was checking my microphone. Am I audible?
Yeah, you're very much audible. Thank you.
Thank you.
So, this is our educational background, right? And like, what are the fundamental expertise that is required? Means in terms of curriculum, right? There is statistics, mathematics, right, and domain expertise, and machine learning, deep learning, any even one programming language, right? Any programming language and any
ठीक
so yeah. So and likewise, we got a complete glimpse of it, right? Glimpse of what is required and what is, because this is very important. Because if you don't have first is okay, if you don't have the objective, so everyone is like when I started, even I, so everyone talks about machine learning, deep learning, artificial intelligence, lot of things, image processing, natural language processing, lot of these things. So we get confused. Okay, what is that we need to know, right? So that is where we baseline, based by the orientation programs to baseline, like, okay, these are the things that are available. It's a vast number of technology that everything is that is available in data science. But what we need to pick and how do we pick based on our potential? That is what we discussed. Okay. So now these two classes, today and tomorrow, is a kind of bridge classes. So earlier we never used to have this. Why recently we are covering this is, again, orientation gave did not get into too much details of what we are covering. So in these two bridge courses, what we try to do is, again, we try to get little one level above, like from the orientation, same things we try to cover, but go one level above into the curriculum without getting into details of the subject, or without getting the details of the algorithms or the techniques. We try to tell why and what those algorithms do, right? So we try to get that glimpse of it. Okay, so you will have a complete picture of, okay, what you are going to study in the future classes when in detail. Suppose Excel or machine learning, what kind of algorithms you are going to study, so that you can picturize and visualize, and like what kind of projects you need to take up, right? So that you don't miss, or you miss, if you want to really miss some classes, then which classes and all those things, right? We need to know that. Okay, that is what we are going to stress in these two classes, the bridge courses, right? Okay, so this is today's is the first bridge course, and tomorrow we'll have the second one. Okay, for data science applications, data science projects, any kind of data science use cases, data science reference kits, whenever we are data science pipeline. Okay, so whatever, I think data science, when you talk about it, it will not always mean projects. It can be proof of concept, it can be research project, it can be a complete pipeline of data science project, it can be a delivery oriented data science project, data management project. So all of this, anything you take which is related to data science, right? You always, I think this is the typical thing of data science project is, you need to have data. Data, you call it as data set or data, right? So, and we already know, I think, what is data. I think what we'll do, see, when we get into the actual course, we'll talk about data, meaning what do you mean by data, right? What do you mean by data? What do you mean by information, right? And how are they how are both of them different, right? So we'll talk about details of that. But here, what we are trying to show is, we Start with data for any kind of data science application, project, POC, research project, academic project, whatever. Data is important. And again, data, there are different types of data. There will be different types of data. There will be categorical data, numerical data. There will be um, uh, there will be primary data. There will be secondary data. Right? Lot of this in data itself, there are different varieties. So, but what we are trying to cover here is on the whole. So, for any data set, the input, right? If you take any delivery project, if you take retail or embedded or e-commerce or any kind of project, right, there will be always an input, right? You take the input and then you process it, you execute the project. There will be always an input, which we always make called as requirements, right? Requirements, right? In any kind of here for data science project, it will be data. So, what are the different kinds of data that are available? So with these things we already know. So, but what will happen is, so though we may be using it in some part of our projects anywhere or in a day-to-day life, right? But we may not actually map to what they mean. Suppose alphanumeric data. So that is anyway as simple as it tells. Alphanumeric is a combination of letters and numbers, right? So generally, what we do is just then just a minute, I'm just done. Okay. Okay. So alphanumeric, I think where you would have come across this generally, I think typically every day, I think every 2 months, 3 months, I think passwords, right? We come across passwords. Passwords are always alphanumeric. We tell it should be given as alphanumeric characters, combination of letters and numbers. So no need to get into too many details of it. You know what you mean by alphanumeric characters, right? So it comes combination of letters and numbers. Then text data. So this is this is very important. Text data, right? NLP, natural language processing, the complete domain of natural language processing in data science works on this text data. So when you call text data, it may be as simple as you may talking about sentences, right? You're talking about sentences or paragraphs, but lot of applications are dependent on it in NLP. In NLP, this is natural language processing. So somebody who's interested only in text, the way we process or the way the projects are processed or executed in terms of the data is handled, right? There are different algorithms for text data, different algorithms for image data. So when you pick up text data, right, the algorithms are totally different. Meaning the way we handle it, because here we have letters and words and sentences and paragraphs and then summary. Then so the object is totally different there. For image, it will be different. So when you come across sentences, you'll have documents, right? You'll have documents, and so which can be of again different format like PDF or docx or XLSX, right? XLSX. So whatever, I think a lot of this combination text files. So a lot of these combinations will be there. Okay. So the way we process, typical examples of document processing, if you take, right? So if you take typical examples of NLP. So if anybody of you know, like, okay, suppose if you have the background of reading somewhere or whatever, you can give some examples of NLP, natural language processing, data science applications. Like we'll have suppose we have document classification itself. See, this is a typical example. Suppose if you have news, right? We have a news data set. You have the news data set. So, so in news data set, what will happen? News can belong to any of the domains. It can be sports, it can be politics, it can be entertainment, it can be or agriculture, or it can be jobs, opportunities, anything, right? So we'll get all these news documents or the articles will be actually each will be in belonging to any of these categories. So, so when you have the news data set, and if you want to do document classification, so each article is called as a document. If you want to do a classification or not, you have to classify them into multiple categories like what? Entertainment, entertainment, sports, politics. So like this, right? So each of these, this is a typical meaning. See, when you have text data, the kind of categorization or the type of categorization or the way we deal with data will be different. That is what we are trying to showcase here. Okay. Okay. So now coming to image data. See, one more important domain, it is already broadly classified as image data. So what is image data? Anything to do with images, right? Is image. So anything to do with images is image data. Images, again, you have different kind of images because you have Excel plots, which is as the image, right? It can be as a image, which can be form of image. Then you have normal images like, okay, animal images or human images or pedestrian images, vehicle images, animal images, and shapes, geometrical shapes, right? And also it can be in the form of image. Geometrical shapes, when you are processing as data, you can't have it as a text data. You can have it as a image data. Figures, anyway, in textbook, if you take, so in text, if you take document, right? Document has text data and image data. So when you have text data, it has to be processed using text processing or NLP, natural language processing models, and the diagrams or the figures of that documents has to be processed using different algorithms called image processing models. So graphics is okay. Normally, when you have curves, when you have plots, right? When you have plots, multiple plots, whether histograms, bar graphs, pivot charts, or a lot of these things will belong into graphics. And trade when we show the uh, trade, what is the trade or what the demand, supply, and all those things. So usually use graphics for it. Then we have the shapes. Shapes can be geometrical shapes, or it can be again like circle depicting some tradition or whatever, right? That is shapes. Figures is again figures. I think most of you have already worked on that. Okay, documents will have figures, or your project will have a lot of figures, different figures, or and again typical use cases would be typical use cases to tell is suppose traffic. So the traffic light. Okay, if you automated car, right? If you take the automated car and it has to uh, at the traffic junction, it has to see whether pedestrians are crossing or not. So what we do, it takes the images, of from the at the traffic junction and processes it to find whether those images has a pedestrian in it or not. It's a typical example, one of the examples. So a typical, generally a what you call hello world program for image processing data in data science applications is dogs and cats problem. Okay, when you call dogs and cats, it is so wherever generally when you work on these projects, right, you find dogs and cats problem. What is dogs and cats problem? So you'll have images of dogs and you'll have images of dogs and you'll have image of cats. Okay, and the model has to classify the given image as a dog or a cat. So the model is built using the images of cats and dogs. And when you give a new image, which is having either the image of a dog or a cat, the model should be able to predict, okay, this image belongs to cat, or this image is of a dog. So that is a typical hello world example in image processing. In NLP, natural language processing, it is like, okay, classifying, that's what I think, news articles I told, right? Given a documents, how do you classify them into different classes, right? It can be news articles, or it can be any kind of documents, medical documents. You need to classify into different category of medical field, something like that. So typical hello world problem for NLP, right? So these are the this is what comprises in image data. See again, see for NLP, for NLP, the input data, right? Input data will be transformed into a different format for the models to process. Similarly, for image processing, it's an image, right? It consists of pixels. Suppose let us take a image of a cat and dog example. The cat and the image, dog image would consist of like minimum size will be 28 cross 28. Means 28 pixels cross 28 pixels, right? And up to, it can go up to, I think, a bigger image if you take, it is 128 or 100 cross 100. So the input will be 28 cross 28 pixels in the image processing model, but there it will be text, meaning news articles. If you take, it will be take some 100 words, the article of 100 words, it will be one input sample. Here, image of a cat or a dog will be one input sample. There, image, there the content of one article, which will be a sequence of words, right? So here directly images like, okay, pixels, 28 cross 28 or 100 cross 100 will be the input. So their words need to be converted into word embeddings that we will see. I think in our future, when we get into details of these NLP models, we'll understand that. So words cannot be directly fed, because words are like textual characters, and how it is stored in our computer memory, it will be Unicode character, right? And generally we will not process character by character. We process it as words, because we need to understand the sequence of words, right? What comes next, what comes before. So that's why there is something called word embeddings. So each word will be represented by its word embeddings. So that's why I'm telling, processing image data, processing text data will be different. That is what we are trying to understand here. Okay, so lot of see, when you tell NLP domain itself has lot of use cases, like document classification, multi-op, question and answering, chatbot, question and answering, robots. So neuromorphic projects. All these projects are based on a lot of these use cases. And sentiment analysis, meaning given a review in Twitter or Facebook or a movie review, can you tell, okay, whether it is a positive review or a negative review, right? Typical. And the recommendation, whenever somebody has given a review about a product in any retail site. So we need to know, like, based on the reviews, can we tell the sentiment of the product, whether it is having positive feedback or a negative feedback. So those are n number of applications there in all domains again, right? So I don't want to again repeat that. Okay, it will be in all domains. NLP has its own use cases, and image data has its own use cases. So image data, when you come across, it will be like identifying satellite drone project, where we need to, in the parking junction, we need to identify where the free parking is there, or wherever there is hazard in case of natural calamities. We need to know where the people can safely move. So it has to understand, it has to take the images of the picture and see where it is safe parking, right? You need to find, or we need to, or if it, one example I think we already discussed is automatic cars, right? There is a lot of things on automatic cars, image processing, right? It has to understand whether the pedestrians are crossing at the junction or not when during the traffic at the traffic junction, and while moving, which vehicles are coming, which vehicles are far. So that is automatic. Again, for robotics, when they are handling, right? And then face detection, object detection, right? And a lot of this fault detection, fraud detection in assembly of manufacturing products. So a lot of image processing applications are there again, right? So if somebody wants to do become an expert in one of these, I think they can become. If they want to do in both of these, that is. So what we are trying to tell here is based on the interest, because for one computer vision expertise, we need to get more fundamentals of computer vision. In the other one, text data, we need to understand more with respect to the text data, how to analyze text, how to represent text, how to vectorize the text, right? So it has its uh, uh, own fundamentals. Okay. Then comes the audio. So as you all know, I think audio is like, okay, human voice and other sounds. So typically human voice, but it can be other sounds also, right? But most of the applications, what we work upon, it will be a human voice. For example, if you take Alexa, Siri, or many other Google Home, or many of these things, right? They are working on human voice, right? So a lot of these applications now, if you see in WhatsApp also, you have an icon where you can we can record our audio and convert into text and then reply back. So, and even in Google it has come up, I think, where there is a microphone icon, you can press that and then search for whatever you want, or whatever you want to search in Google search, right? So a lot of this. So again, audio as is, see, audio processing is totally different again. See, because audio is not image, audio is not text. So if audio is converted to text, then I think it becomes text process. But audio as such, themselves as a whole, will also, audio data itself will also be processed in a different way, in a different manner. It has its own approach of processing, where we convert them into a Fourier transform. We convert them into a waveform. We convert them into a waveform using Fourier transform, or we convert it to image, waveform image, right? So of different frequencies using different methods, and then process it. So different kind of application. Suppose typical example, which is more relatable very recently, is that COVID. During COVID pandemic, right? Lot of applications were built where based on the cough, right? Screening. When we want to do the screening, people are allowed to cough based on the cough. So we are supposed to screen. I think a lot of applications were built where it was supposed to screen whether the person is predict whether person is having COVID or symptoms of COVID or not. So that is a typical application. A lot of like this typical application which we came across recently. Likewise, there are a lot of applications where we need to process, especially in medical field, right? That is very useful, where people want to diagnose, right, based on their vocal pattern. And similarly, I think we had the example of Siri and WhatsApp or Google search or many other applications we studied, right? So these are their own applications. So again, I think if we have the background of what you call signal processing, or so those guys, I think, would be more interested in this, because the way we process this audio signals is will be different. Or we need to understand the background, means fundamentals of how we process the audio data, right? Then we can build the expertise in that yourself. Set of values of qualitative and quantitative data. We'll understand this. There will be different types of data itself, qualitative data and quantitative data. In qualitative there will be different types, and quantitative there will be different types. So we will try to understand. So data does not mean only data. It can be qualitative or quantitative. So that's what we were discussing in the start of our class, right? So data as a whole means, okay, very simple, but I think when we get deeper into it, right, statistics of data, there will be statistics of data, and there will be different types of data, right? And how do we handle these different types of data? One was, okay, I think at a high level we spoke about alphanumeric, text data, image data, audio data. Similar wise, statistically they have been divided into multiple different types of data. That also we will study. Raw material or facts. So how do we get data from? Where do we get data, right? So some data can be from the raw data, like, okay, COVID data, whatever we spoke about, right? That is raw data. Means we get it directly from the source. So that is raw data. Some we get it derived from the facts. So suppose we have the textual data, or we have some books or reviews. We need to derive some data from those text or some of the facts which are already available. So that will be factual data, right? We will see that. Okay. So limitless and present limitless and present everywhere in the universe. So what we are trying to tell you is, I think data is limitless. I think there was a number like, okay, millions and billions of data is churning out every day, and every day meaning it is not going to end, because everyone is tweeting, everyone is medically we are storing some data. Every day we have patients and they'll be storing medical records. Every day I think traffic instance vehicles are moving, so there'll be different types of data, anomaly data, manufacture assembly, there will be different type of each day. And in uh, in the universe itself, if you take, right, wherever each nanosecond, I think an enormous number of data is being generated. So data is limitless. It will be in future. That's why I think a lot of these data science projects are in demand, mainly because data will not be ending, and we may get new type of data. See, I think the specialty of this new data is what happens. The models whatever we have built, right, they may not they may be built on historical data, the current data, right? So in future, I think similar kind of data also may get generated, or there may be differences in the data that has been generated for the same. Suppose if we take an example of bank data. So suppose we are trying to predict whether uh, what is the interest rate, okay, a person can get based on his investments. Okay, so that is a typical model that we are trying to build. So right now we have some historical data of 10 years, and based on that we are building it. 10 years data is there, past 10 years data of all the customers, and then we have the current rate of interest and current FD rates or whatever, right? Bank policies, everything. We feed in all those data, and we build a model. And based on the data, we'll be able to predict, okay, given a person's attributes, like, okay, the amount of investment he makes and whatever credit score he has. So based on that, we need to predict what is the benefits he gets from the bank. That is the model we have built. But same model will not be generic for future years, because in future or the coming year or in the next year itself, the interest rates may change, right? Of the SP or FD rates or policies of banks can change, right? Policies can change based on the government. Based on the government can change some policies. So obviously, the benefits he gets for the person, same attributes, the same person who what he was getting current year, he may not get the next year. So in that case, what happens? We need to change the model. So general, when we are discussing this, what comes to our mind? So does that mean that, okay, we need to rebuild the model with all the data, with the old data and new data, and then see? Because old data has some data, some attributes of the customers, and we have some new data. So you merge this data and then build a model. Yes, I think this was the case a couple of years of back. But now there is some concept called incremental learning. Incremental learning meaning whenever you get new data, you use only the new data, and use the model which is built with the old data, and try to update that model using the new data. So those are the. I think what I'm trying to tell here is a lot of innovation is happening in the way we are building the models, depending on what kind of data is available, what kind of data is going to get generated in the future. So this is an ongoing process. So each and every month or each and every day, I think we have new models, new techniques in data science, right? So so that's happening. That will happen. That is happening because it is evolving, and the data is not stable. So obviously, but we'll not. So for our curriculum, we'll not get into like, okay, to cover everything. It's not possible. I think we require 1 year or to do a post graduation to know the latest and complete curriculum of data science. But what we are going to cover, we will be covering is fundamentals to understand all this, whatever we discussed. So if you know a set of algorithms, set of techniques, set of approaches, which gives our the foundation to learn whatever is new. So that is the background we are trying to build. So if you know ABC, then we can build the word. If you know how to build the words, we know how to build a sentence. If you know how to build a sentence, we know how to build a paragraph. When you know how to build a paragraph, again you can write a document. So that is how we are trying to see how to learn the alphabets and the words and how to build a sentence to that level, right? So then I think using that, I think you'll be able to write paragraphs, documents, right? Different types of documents, category of documents that will be able to helps in production of information. So data as it is useless. Any data is as it is in its raw, it's useless unless it is processed. When the data is processed, it becomes information. So if you are able to understand something from the data, that means it's information. We will see what is data and information in the further classes. But so data helps in production of information. So if you have data, you can get information out of it, right? Yeah. So this is, I think, one of the slides I think we discussed during our orientation program, right? So to understand data science, right? So data science in the middle, right? We have data science here, meaning to data science includes all these fields, right? You need to have bits and pieces, the knowledge of these fields like mathematics. So you need to have the background of mathematics. You need to have the background of. You need to understand the fundamentals of machine learning. When somebody calls themselves a data science engineer or data science analyst or data scientist, right? So that means that, okay, you have a blend of these fields or these domains. So at least you'll understand what is a machine learning algorithm or what are different types of machine learning algorithms. So you have the background of mathematics like probability, calculus, or differentiation, basics, right? We will not get into details of it, details of integration or calculus or linear algebra. We will not get, but basics of it. And statistical research. So you should understand the statistical models, hypothesis, right? Probability, descriptive data. So things like that. I think we are going to touch base on those. I think we'll have some classes on statistics itself, some three classes, I think, on statistics itself. Mathematics also we'll try to cover, and machine learning, anyway, we have a couple of classes on machine learning algorithms itself, right? And computer science, I think or the programming language, whatever we are learning, right? We try to cover that as part of the Python classes. I think we have some 3 or 4 classes on Python, and we have some 4 classes on R language also, so which will cover like the computer science, the programming background that we require. Data processing. So this is also important. Data processing here, it means that's what we are trying to discuss in the previous slide, right? The different types of, we need to understand as a data scientist, we need to understand what are the different types of data available. How do you process each of these data? Because if it is image data, it is different. Text data, it will be different. And audio data, the processing will be different. So we need to understand that in detail. So that is one. There's a different field altogether. Means we'll understand. Means data processing itself is a major step, a major component in the data science pipeline project. We have a data science pipeline, right? The data science pipeline. In the pipeline, data processing is a very important component, which comes in the start of the pipeline. So there will be different approaches of handling data processing called data pre-processing actually. Data pre-processing means before we feed the data into the model, before we build the model, right? Means we discussed that, okay, we require the data, right? Like cats and dogs. So cats and dogs. So right now, as of today, somebody has cleaned up the data and they put the images of cats and dogs separately for us. but it will not be straightforward for us, right? For the other examples or any newer examples, if you take, right, if you want to categorize birds, so somebody would have not done that. But then what they may do is, okay, they will give the picture of birds, and each image may have two or three birds or a number of birds in a image, and we need to pre-process it. We need to pick the right bird, or we need to separate that bird, and we have to clean that. We have to make them as proper size. So each image should be at the same size. We have to clean it. If there is a noise, suppose if the only beak is only half of the bird is seen, then we need to discard those images. So like that, I'm giving such example. But when you're handling NLP or image processing data or audio data, right? You may have a lot of noise. So in sometimes we are lucky that, okay, we will have the data set available. I think since the machine learning and deep learning have been evolving since long years, I think a lot of these data sets are already available. They're already there. But for some use cases which is based on the current scenarios, like based on the COVID pandemic, when I was working during COVID pandemic, one of the project, right? There is cough samples. So it's not so easy to get. First is, okay, we have licensing and agreement issues there, okay, compliance issues. So we need to get the data itself. So from the hospitals and from the patients actually first have to agree, okay, it can be shared, and then the hospital should agree, okay, should get the consent form from the patient, and then when we are working with the hospital, we need to sign an agreement telling that, okay, we'll not use for some commercial purpose or whatever, or such purpose we are going to use it. And post that, we need to know whether these cough samples, no, not everyone would have coughed in the right manner, right? So when we tell them to cough, they would have coughed in whatever the way they want. Okay. So then we need to denoise it. We need to clean that, right? So why I'm giving this example here is, I think many a times we may not have the historical data at all. We'll always get the raw data. We have to clean it ourselves. So that's why data pre-processing or data processing also is a very important component in data science project. That's why it's been listed here. So it may look, okay, like any other pre-processing step, but here it is complex because everything is dependent on data. Domain expertise, I think that we already discussed. Domain expertise is, so each data science project maps to one of the domain or cut across multiple domains also many a time. So why this domain expertise is required is, see, when you start a project, we may enter the project at different stages. A project where we already got the data set and we know what to build and what is the machine learning model we need to build, and we know that. Let me check if there's something else. Okay. So domain expertise, meaning, so typically, I think I'll give an example now. I think same COVID screening app which we were building, right? In that case, what happens? What is the advantage? What does the domain expertise do here? Okay, if you have the expertise, if you already have the expertise of audio, processing the audio samples, right? That is the domain expertise, and you know whether we have the right cough or not. So generally, I think if we are not from that background, then we'll not be able to tell, okay, is it right cough or not. Then we need to go back to the domain experts. We need to go back to domain experts and understand whether the cough what we have got is right or not. Because just based on some visualizations or just based on some sound, we'll not be able to tell. We need to have the domain expert. Suppose it can be a doctor, right? Or it can be a clinician, which will be able to tell us, okay, this cough sample is right or not, we can consider it or not, right? So even in retail, suppose we take an example of retail domain, when we are doing customer recommendations, product recommendations, we're going to recommend some products to a customer, right? Then we need to tell, okay, based on, we need to discuss with the domain expert, telling that, okay, these are the products which which are coming out of the recommendation, can we recommend it? Then the domain expert should be able to tell, yeah, it is in stock, out of stock, or it can be produced, not produced. So he'll have some expertise on that, those products. So though the models will predict, we'll be able to, as a data scientist, we'll be able to predict and build the model and pre-process the data and whatever, right? But in each of these stages, right, we may require a domain expertise. If we have already have the domain expert, many times what happens, we ourselves, because we are working in the same domain for multiple years, we would have got the expertise of it. So we'll be also have the domain knowledge. So if you don't have the domain knowledge, then we need to involve the domain expertise. So one other example is see the pneumonia detection. So the pneumonia detection, right? So you have the X-ray images of the lungs, X-ray images of the lungs. So you feed in the lungs images, and then the output will be whether the image as shows the signs of pneumonia or not. So normal, whether the X-ray of the person, whoever it is, right, that person has pneumonia or is a normal, whether it is normal. So after prediction, so there will be always a percentage of error by the model. So, but how do you tell, okay, whether the model has done told correctly or not? We need to, one is, okay, we already have got the data, okay, it has been labeled, but in spite of that, for labeling the data, whether this is pneumonia or not pneumonia, we need to consult a doctor. So before feeding these X-ray images, they need to be labeled, they need to be annotated, telling that, okay, this X-ray image is pneumonia or this X-ray image is normal, right? So that we can't do it. We need to get the doctor's expertise, right? So this is all about, this is the background of this particular slide, I think. So again, I think as we discussed in the orientation program, not necessarily that, okay, we'll have, we need to cut across, we'll have cross skills. We can, one is, okay, if we don't have, we need to develop some of these skills. If we already have, we can upgrade those skills, right? So basics of any of these, right, all of these, especially all of these basics of all this is very important for a data scientist. Again, I think this is for data. What is data? Data, I think we already data. So from where the data can come, right? What is data? So what do you call it as data? What do you call as data? Whether I told about bank information like customer attributes, right? How much loan he has taken, how much SP has kept, and what is the how many years is there in the bank. So those are one of the attributes. That is also data, right? So what are the other types of data that you can get, right, in different data science projects? One is measurements. Sometimes measurements, whatever you measure, the measurements of a particular machine or product, right, used or can be used for anomaly detection. Whether the particular instrument is generating the right type of data or not. For that, we'll take the measurements of the instrument and see whether, and we'll do an anomaly detection. We'll build a model for anomaly detection. That is there. The input is measurements. Data is the measurements of that instrument. Observations can be whatever. I think we told just now. We talked about retail customers, right? Online retail customers, online customers. So they buy and they give the feedback. So, and the feedback of all of these customers are the observations for us, right? We need to tell whether a person, whether the customer, whether the product is doing good or not, whether the product is rated, whether the product is marketed well or not, right? That is based on the observations. We take the observations of the customers, or the feedback of the customers, the views of the customers. Based on that, we build the model. So there, the data is based on the observations, is built on the observations. Facts, again, these are facts. Some are scientific facts, some are like, okay, facts about a product, right? Somebody gives specifications of the product. So based on that, we need to tell whether the product is good or not. We have multiple products and we got the specifications of the product, and we need to tell whether the product is good or not based on the specifications. So those are there. The data comes from the facts Facts are either true or false, right? This, if it's in our case, when it's a specification of the product, it is all real facts and true facts. Right? Numbers. I think this. I think we know. I think n number of n number of examples will be there where we have numbers, whether predicting the housing price. Predicting the housing price will have. Suppose we want to predict the housing price in a particular area, then we have a lot of information about it, right? So they'll be all based on numbers, price of the house or price of the apartment. So all those things will be based on numbers, quantities, real quantities, right? So so this is again some of our use cases can be based on the quantities, amounts or the quantities, amount or the quantities. Information is again generic, right? Whatever you extract from data is information. That is, so data as such is not useful anytime. We have to extract information from it, and that information we pre-process it to build a model. Graphs is, I think, they build the trend. Graph shows the trend. Graph shows the observations. Graph shows the demand and supply, or it can be a lot of these things, right? It is plotted against multiple axes, right? And it will show the um, trend of data. So those also can be data input for some of the models. So there are graphical models, there are graph based models, right? Graphs, one is these graphs, other one is knowledge graphs. So the other graphs called as knowledge graphs, which is based on textual data, right? See, Wikipedia, if you see, it is built on some kind of knowledge graph. Initially, you'll have each Wikipedia article will have an introduction. Then you will have something about the background, earlier life, or whatever. Right? There is a structure for it. That is, and when you build it as a graph, right, it becomes a knowledge graph. Right? There is a knowledge graph. So lot of these models are called graphical models. They are built on graphs. So graphs does not be always images. It can be knowledge graphs, and there is some other different types of graphs also available where we'll have symbolic graphs. Based on that, we'll be able to build a program synthesis. Means there are some models which will generate the program. Given the graphs. Given the gra- Okay. Anybody have any questions? Okay. So these are the typical, meaning when you build models, right? When you build models, so there are different ways of the input data, different ways that the data which comes to these models will be in different formats and be different type, right? That is what we are trying to know. I think to visualize yourself, right? When you are building the model, right? We see before attending this class, there will be general the visualization of what a data science project. When you talk about data as input data to the data science project, right? You will have some kind of perception about it. So just to elaborate or broaden your perspective, right? So we are trying to elaborate on what will be the what attributes, what are the attributes that are involved at each component in the data science pipeline. That is what we are trying to give a broader perspective, so that the visualization, the perspective in our mind, right, gets broader. So that's the main intention of this bridge course. Broaden our perspective. So there we gave based on the content, right? Based on the based on the way data, based on the based on the based on the type of data, or the based on the where from the data is got. Based on that, we classify it from where we have got, right? We classify that data like graphical data, textual data, image data, and all. That is a generic way of doing it. Now, each of this data, each of this data can belong to any of these domains. We already are talking about this, right? So now these are the types. Where can the what types of data can be processed? What kind of data are we processing for data science models? What kind of data, right? This is again a small subset, but it covers most of the domains. But it is again a subset. It's not covering everything, but it gives a perspective of what kind of data can be processed. What is the type of data that we are processing? Geographical data for maps. When you're building the maps, you want to tell which route is better, right? Which, suppose if you take Google Maps, right, or any kind of map route generations. So it has to, and nowadays I think forget about Google Maps. You have that any kind of this online apps like Swiggy or Mato or any kind of this food processing apps, right? So they also, I think, when they want to some source to destination when they want to travel, right? They need to give an optimized route, right? So they use this geographical data, and try to see what is the best route, right? And geographical here can also mean um, finding a map when you are traveling, right? Finding the route when you are traveling based on traffic, and given the shortest distance, and when you're, and if it is blocked, and what we should do, what is the alternate routes, right? And a lot of innovation is happening there also, right? It's not only that, okay, it will give optimized routes or suggest what is better based on the weather, right? Based on the weather, it will tell, okay, in that region, if you're going for long routes, it may even suggest, I think it's going to rain there, and you have to take this route, that route, right? Based on 2 hours prediction, it will. I think that kind of innovation also is happening there. A lot of these things. It shows the satellite image. It gives the view of the roads, how broad it is, or what is nearby there, right? So those kind of things. And as you're traveling, it will recommend what are the nearest outlets, retail outlets, what are the nearest fuel stations, right? Fuel stations, and what are the nearest eat outs, restaurants, right? So those, a lot of these innovations are happening over a period of years, right? In this transport here again, I think pedestrian detection or automated cars, and then object detection to prevent the accidents, right? To prevent the accidents, and at the junction when you are stopping, whether the pedestrian is crossing or not. Traffic, traffic camera object detection. When you're already stopped at the junction, whether somebody is crossing or not. So those kind of lot of these transport-related applications are there. Natural, that is nature-based. I think this is also very lot of these things in agriculture, right? Agriculture and plants, and then a lot of related to nature. A lot of these things are happening, especially in agricultural domain, right? A lot of this fertilizer-based, irrigation-based, crop-based. So a lot of innovation has happened there. A lot of projects have been built. That is an ongoing process, because it's like bread and butter, right? And it's always evergreen, right? The field is always evergreen. So a lot of innovations are happening there. And it was untouched, especially in data science perspective, and the AI perspective, it was not untouched, and it requires day-to-day monitoring, and we need to see the results. People will not wait for years to see the results. They want to see the results as early as possible, right? So that's also very demanding in agriculture field. Metallurgical. So this also, I think, probably whoever is seeing the news, and whoever is working with the metallurgical department, right? Weather forecast, calamities prediction, earthquake prediction, or thunderstorms, lightning, rain, type of climate, right? Especially for even for agriculture, when it would rain, and all these things, right? As a lot of innovations happened there using the art of this meteorological data, precipitation, humidity. So you lose all this kind of data and predict when rain can happen. And especially when we're building the smart city, So I'll give an example how it is cross skill, right? When you have a smart city and the solar panels, when your people are trying to go green, right, and they are building this lot of solar panels, smart solar panels. Solar panels is already available, but they are building smart solar panels where there'll be a smart meter to predict how much generation, how much energy generation can happen today. So that will be based on the weather weather of the day. So what will be the weather of the day? Whether it's going to rain or how much sunlight, whether it will be very hot, what will be the temperature of the day? Based on all those things, a smart meter will be built, which will be connected to these solar panels, and it will be able to predict really that okay, this much energy can be generated. It's going to predict that. So that kind of innovations are happening where multiple energy sources, right? Energy sources like wind tunnels or solar energy, solar panels, right? Biogas, lot of these things. They're using all these renewable energy resources and making predictions and alternative energy resources, right? For so all lot of these innovations are happening. Right? A lot of these things are going to come up in would have come up in some places in I think in Gujarat and other places also, and especially where they are building the smart cities. I think this is one of the one of the one of the key one of the components. That's what I think. Lot of innovations are happening, but this is one of the components in smart cities. That is what I have. And statistical types of data can be statistical. I think some of these, though, see earlier to machine learning and deep learning, right? All the all the analysis was done statistically. So statistics was a very important field. I think a lot of this analysis earlier was happening with the uh, statistical approaches. A lot of these statistical approaches have been already built. Okay, statistical approaches are already built. See why I think we'll see in the further slides why we are not going to use statistics now, and why did we go for uh, machine learning or deep learning, right? What is the necessity of that? When we already have a solution using statistics, why are we going for this machine learning, artificial intelligence? That we need to know, because if the solutions are there, there will be a drawback, right? And there will be advantages of using the current technology that we will see, right? So statistical data from statistics, right? So many times, okay, statistical data also will be used for building the models. Financial data, I think any banking, finance, securities, insurance, all belongs to financial. So lot of models. I think most of the predominant domain BFSI, banking, finance, securities, and insurance. So a lot of machine learning approaches have been adapted there. Scientific, scientific is okay for research oriented, for scientific reasons, right? For scientific anything related to research. Right? Lot of whatever has been built, especially in data science, right? First, all these innovations or POCs are built as part of the research projects in academic institutions, because see domain they'll be domain generic. So, but when you are working for an organization, right? So they try to build models specific for a domain. But for academic institutions, they cut across the domains. They are independent of the domain. So, a lot of this new research work on data science really happens in academic institutions. Okay, cultural, cultural. I think again we have entertainment industry, right? I think we already discussed that. Okay, a lot of innovation happening there. Okay, and in terms of recommendations, right? What people are going to see, what people are going to like, based on survey, review, feedback. I think they are going to tell. I think they are going to change. They are going to change um, the what do you call some decisions of major events in the entertainment industry. So that's built on AI. I think even in a couple of these things, right? When Trump He had a suggestion from one of the experts, right, where he was able to tell whether Trump will win or not, right? I think based on the what do you call that pre-polling, right? Pre-polling statistics. I think they were able to tell that. Okay, that kind of it cannot be 100% correct, but people are innovating on that also, where it will be close to real data, close to the real polling, right? Whatever polling results come, it will be close to that. I think a lot of innovation is happening there, right? Data requirements. Just drink water. We'll take a 5 minute break now, okay? Just 2 to 3 minutes break, and then we will connect. Okay, I'll just drink water and come back. Okay. Okay. So let's connect back again. So data requirements. No, no, you have something? Okay. Data requirements. Okay. So so far we learned what we learned is what is data, right? What is data? Different types of data, different types of data, and different category of data, different category of data, and how means from where, right? What are data we can get? What are the uh, like okay, text data, image data, audio data, and then from where we can get those data, like different domains, and how do you process the data? So how do what is this data same or not, right? For data processing same for different types of data or not? So all that knowledge we got now, right? Basic knowledge, basic knowledge like how to what is data, how do we process data, what are the different types of data, from where we can get data, and how difficult is to get data. So sometimes data is easily available, sometimes we have to pre-process that, clean it, right? So a lot of this we may have to work on the data to get the to make it feasible for a model to consider it, process it as an input. So this is what it talks about. See, data when you have talk when you have when you talk something when you have when you work on a data science application and you are given the task of collecting the data, means preparing the data set. You may not call the collection is part of the data preparation step. So there is a step, right, called data processing, pre-processing. See, in that again it is divided into multiple steps. Okay, data preparation, data collection, data preparation, and data analysis. So anyway, we'll read that. I'll just put it here. Okay. So when you are collecting for, when somebody gives a task of data processing for us, right? Suppose they give the task of data processing for us. Let's take the task of data processing. Data processing. So first we need to do data collection. Data collection. Next we have to do data preparation. Next we have to do data analysis. This is also called as exploratory data analysis. Okay, then I think a lot of other steps are there, but for now, for this current whatever knowledge we have got, so data processing. So first we have to do data collection, then we have to do data preparation, and then we have to do data analysis. So when you're doing data collection, right, so we need to know how to see. This talks about do data collection. When you are doing data collection, first of all, we need to know how to get the data. How to get the data, right? Meaning that is the basic. See, suppose this COVID screening app, we thought, right? How to get the data? Where? Meaning you can't just go to house to house and get the cough sample, right? Google has COVID or whatever. You can't do that, right? There should be a source. There should be a source from where you can get the data. How? How? We need to know how. So it may be clinics, or it can be organizations which are health organizations, right? health organizations which are supporting that. Okay, then it may be hospitals. It may be hospitals, right? We have to collect from there. It may be some clinics, right? Organized clinics, legal clinics which are supporting it. We need to know from how and where. Say how and where, how and where we need to know. So how to get and how to do. So this will add a lot of this legal issues, right? We need to cover the legal issues, compliance, and there will be agreements also. So this legal issues will also have this copyright, right? Copyright issues also. Okay. So that's very important. Meaning we can't just directly think. When I was working on this COVID, right? So we felt, okay, what is there? I think we can get some data from hospitals and they'll share it. So it's not like that. There will be a lot of legal procedures for it. Okay, then only we can get data, and not all hospitals will share data for everything, because there is political, I think, political issues also there, because everyone wants to do research and come up with their app, right, as early as possible. So some hospitals will share data with some organizations, some will not share with those, some will share with something else. There may be monetary issues also there, right? So a lot of these things. So it's not very easy to get data, right? So some data which is public, which is publicly available, which is public source, right? Working on that would be straightforward. But when you're working on something which is important, which is works at the cost or some particular cost, then I think it is difficult to get. Then who is going to provide it? So who is going to provide it and who is going to work on that? So they will be called data miners. Data miners or feature engineers. We may call sometimes as feature engineers. Feature engineers. Okay, they may call feature engineers. Who is going to work on that? And what is that? What is the data? What we are going to do with the data? What are you going to do with the data? So your data, we are going to do the data preparation. Okay, you are going to do the data preparation. First, we are going to collect the data, then we are going to data preparation, then we are going to data analysis. We have to analyze the data and see whether the data is proper for us to model it, right? Whether it is the right data or not. So what are we going to do with this, right? What are we going to do with the data? So we need to be clear on that. And why? First of all, so when you have this data, why do we require this data? Why do we should know the end goal? So you are taking the cough samples. You're taking the cough samples. So what kind of cough samples require? All cough samples are, right? So what kind of cough samples you require, or what mode is required, what format you require. So we should know why we are collecting the data and for what purpose, right? We should know that why we are collecting this data. And when you see some kind of cough samples, when we what was this COVID disease, there were the cough samples which were available some years back. They were based on this. What was that? Pneumonia. See, when persons have pneumonia, also they will cough. So the cough samples are collected for different diseases. Okay. So there were some cough samples, and they see what used to happen during COVID time, right? When we started, because it was the start of when pandemic also started, and there were not enough samples. So when there were not enough samples, so we had some cough samples which are based on pneumonia cough samples. Okay. But this COVID, the doctors used to tell, okay, it's the COVID coughs are related to pneumonia cough samples also. Meaning some person who is having pneumonia, the way he cough and the way COVID person is to cough, there are some similarities. So to start with, let's start with the cough samples of pneumonia, right? That is what it all started. So sometimes we may not have the data when we start the project, right? So can we then, when can we start the project, right? The question would be, when can we start? When is the data requirements? When can we start? Then we may have to look for a secondary data. before getting the primary data, we may have to work on the secondary data. So in that case, we should do the data analysis and come across what other data, alternative data can be used. The COVID example, I think we had this pneumonia, which is cough samples were open sourced. So we started with that. We started to build a model, and why it's important here is because the cough samples, we should know how to process that cough samples, and what kind of model need to be built, and what kind of how do we collect the features of that samples. So all those things will get the knowledge before we get the actual samples. That's why. So we need to work on the alternative when we can get the data, and what is the alternative source for it. So that also need to be worked upon. Yeah. So this we had covered the orientation, I think at a very brief level. So I think this is, so let's see where we start, right? We have covered most of the, okay, from here, here, see? Okay, here. So we start here, and what we are trying to do, this is the question. See, this is, I think, this is the picture I think you should keep in your mind for data science project, right? Data science pipeline, we call it as data science pipeline. So the first step, so when you are working here, so we discuss this, right? So we are here, we know that now. Why, meaning why we are doing this project and what kind of data required. So all this, what we require, what not required, what is the goals and objectives, what is the objective of the project, what is the objective of the product, what is the data requirements, what are the data requirements, okay, and objective. And later, I think during this phase also, we also try to build what kind of models, right? What kind of data models need to be built, okay? What kind of data science models can be built. So all this why and why we are doing this project, what are the insights it gives, right? What are the insights it gives, and what is the advantage of those insights? What are the pros? What are the pros and cons of this building this model? Means how it will be useful. And generally, I think whenever you are working on any kind of organization, right, always it will come across revenue. Means how can it generate revenue? Meaning if it is going to automate few things, so what kind of revenue you get, right? So all these are done here. Okay, exploratory data analysis. Okay, why? Okay. Then we have the data acquisition. So suppose that okay, you are defined. Okay, you are going to build a data science project. Okay, then we need to start from the first stage of the data science pipeline. What is this? Data acquisition. So here we already discussed. So we can use databases, APIs, online repositories. That is the public sources. We need to collect the data. This is data. I think these are all the three steps. Data acquisition is data collection. This is data collection phase. That is data acquisition. So that we discussed earlier, right? Data collection. That we already discussed. So you can use whatever, I think different modes of accessing the data. You can use web servers. You can use databases. You can use APIs. You can use online repositories, right? And then once you get the data, once you have the data collected, we need to clean and transform. So transformation also is a very important step, which I did not talk. Transformation is first is cleaning. First is cleaning is like, okay, if there are inconsistent data types. So in the same, okay, whatever you feel, right? Okay, suppose there is an inconsistent data type. So suppose you take review types, right? So one is in English and one is in some other language. Then they are not in the same type, right? So we need to change that, or we need to either remove it or translate it and keep it. And then we have any question? Misspelled attributes. Misspelled. So this is like missing data, misspelled attributes. There is something called missing data. Missing data. So there is different ways of handling missing data itself. If data is missing or if it is misspelled, what we need to do? Either we need to remove or ignore or replace with something else. So that we'll study that. Okay, we need to handle that. It's also part of cleaning step. Then we have missing and duplicate values. Misspelled. If it is misspelled, how do we handle that? If it is missing and duplicate, then what do we do with that? So those kind of, and for that we need to transform. We need to transform that. Okay, you identify this, and then we need to transform. Suppose there is, suppose the data are of huge values. Okay, it ranges from 0 to some 10,000, right? We may have to scale them because other data type is ranging from 0 to 100. So then we have to scale this also from between 0 to 100. So scaling, normalization. So a lot of steps are there here in transformation. So that is the next step. First is data acquisition. Then there is this entire this thing. We saw that, right? Data collection, data preparation, and data transformation. Data preparation. This is what we studied earlier. So this is completely data preparation step. Okay. Data exploiter analysis. So once you have the data ready, once you have the data ready, you need to do the explorer data analysis. What is explorer data analysis? You need to define and refine. Okay, so you have variables that will be used in the model development. So this is the explorer data analysis. Okay, you have suppose some 40 attributes you have got. 40 attributes. Okay. Battery attributes, or we call it as features. After doing data cleaning and everything, you analyze and found that, okay, 40 attributes or features you have got. But all of these features, right? All of these data features, like, okay, suppose like let's take an example of if you want to predict the price of an house in a different area, and the attributes are the area name, pin code, and then type of house, okay, one single bedroom, 2 bedroom, 3 bedroom, okay, and road width. So a lot of these attributes are there. There may be something like a park available, park nearby, or school nearby, or temple nearby, or hospitals nearby. There may be something like retail mall near, supermarket nearby, bus stand nearby. All these attributes, yes or no attributes are there. And there may be something like, okay, open space, playground nearby, right? And there may be, so for some of these, right, some of the options may not be relevant for us. Like, okay, playground nearby, not many people would be interested in to have whether playground is required or not. So we may not have to keep that attribute, right? If the proportion, if there are 10,000 samples having these attributes, and then out of 10,000 samples, if 9,000 of people are telling playground is not required, and 10,000 of people are telling that playground is required, then is the bias in data. Then it's better to remove that attribute because it's not contributing. Because if you take 90% of the people are allowing that the playground is not relevant. So in that case, why to keep that attribute? Because it does not contribute much, because our model get biased by that data. So those kind of attributes we can remove, right? So those kind of exploratory data analysis, there are standard ways of doing the analysis of the data. So we will study that. Okay, I'm just giving a typical example. Okay, what will be exploratory data analysis? So next is data modeling. Okay, this is the major. This is the actual step where we build the model. When you talk data modeling, do not be confused with the data modeling in what do you call data management, right? When you are working with databases or databases schema, right? So there also you come across data modeling. But here the data modeling means you are building the model, a learning model or deep learning model. right? Building that model. HP. So you're building the deep learning model. You are building the machine learning model. The step is that. Yeah. We, guys, if you're not talking, can you go and mute? HP, I'm not able to hear you. Are you trying to talk something? Tell something. Okay, so and that is a complex step because again, data modeling there also I think it's not a very straightforward step there. Again, I used to do. I don't know whether we are in next slide. It's here. Okay. So data modeling, right? I'll in the next slide we'll talk about data modeling. It's not also. It's not like okay. It's back and forth. We use some algorithm and work back and forth. We'll decide which algorithm to use, and we work back and forth to come up with a best model. Best model. So that's the data modeling step. Basically, the output of this particular step is data model. Yes, you have data model, machine learning or a deep learning model. Okay. Then comes the visualization and communication. Okay, this is very important. Here we saw there are data engineers or data miners. We call as data miners. Data miners. Right? Data miners. So here data scientist. Data scientist. Data engineers. So here we'll come across data analysis. So their purpose, the main purpose is to visualize and communicate with the business. See, after all, you have built a model. You have done a lot of work, right? You have done a lot of work from here. You have done a lot of work. 1, 2, 3, 4, 5. But having done all those things, right? See, the important step is to communicate to the business that why we have built this model and what are the insights that is give and what kind of revenue it can generate. How much it can save? Means what kind of revenue it can generate, right? That's the most important thing. See, we mean sometimes data scientists or data miners may not be able to communicate that right to the business. So data analysts play a key role there, taking the models which we have built to the sales team or the marketing team or to the business, what you call it as business, to communicate through visualizations. They'll not give the implementation details there. They'll use the visualizations. There are different visualization tools for it to showcase the benefits of using our model, right? So they'll try to communicate to the business, telling that why this model has been built, right? So that's why they are very important. They use some lot of statistical methods to showcase that and visualization tools to showcase that. Okay, there are a lot of frameworks that are already that have been built only to visualize and communicate to the business. A lot of frameworks have been built by Microsoft, Google, Amazon. So a lot of tools and third-party tools and a lot of tools are available, which useful only to which are only can be used by data analysts to visualize and communicate to the business regarding the purpose of our model and the insights and what insights it can generate. So life cycle of a data science project. So similar to any other project or delivery project, embedded project, retail project, e-commerce project, right? Application development project or a maintenance project or a lot of different types of projects on there, right? So similar to that, a data science project, right, will have this life cycle. First is business understanding. I think this is common across any project, right? So business understanding or the requirement understanding, or as requirements understanding, business understanding, or requirements. Requirements understanding. Understanding. Then the analytical approach. Approach. We need to know. Okay, you know the business. We know the understand the requirements. Okay. Then we know these are the business requirements understanding. The business requirements we understood, and we have to do the analytic approach. Is whether we need to model that, whether it is good to build the AI model or not, whether we need to use machine learning model or deep learning model. So those kind of things we have to decide in the analytical approach. Then comes this, when you know what project or what to be built or what kind of model has to be built, then you have to work upon these three data. You have to collect the data, requirements. You have to know the data requirements, where, how, what, right? All those we need to answer, right? When, where, right? All those things we study, right? Why, what, how, right? All those things we have to answer, and then start collecting the data requirements. Then we have to understand the data requirements. Then we have to collect the data. Then we have to understand the data. Then we need to prepare the data. Data preparation is again where we visualize the data, do the exploratory analysis. We do all those things. When we do data preparation here, if we feel okay, data is less, data is not balanced, data is biased. Data is not sufficient. Not balanced. And then we have to go back and collect more data and then repeat this step. So this will be in a loop unless we have the right data and we feel that okay, it can be used for modeling. Then you come back here, then you work on this modeling. When you do the modeling, so you see after doing the modeling, right? After doing the modeling, you have built the model. For building the model, you train and validate. After training and validating the model, you go and evaluate and deploy it, and then you get the feedback. So depending on the feedback, if they tell okay, feedback needs improvement, if it needs improvement, then we need to come back and see whether okay, the performance of the model has to be improved, or we need more data. Then we have to go back and collect more data and rebuild the model and retrain it and validate it and repeat these steps. So this is the typical life cycle of a data science model. Here, a lot of things. Again, deployment is a big step here. Okay, we have to deploy it on the cloud. We have to deploy it on cloud or actual this thing, right? We need to know all this. We have to deploy it to the cloud or any other framework, and then we know online training. Whether we have to do online training, right? We have to do online training. Whether we have to do offline training. So all those things comes here. Okay. So feedback is feedback from the business or feedback from the customers. So based on that, we can come back and redo the steps. Typical data science life cycle. We'll go individually. I mean, to understand some of the brief summary of what projects are on each of these domains, right? So some of this, right? Okay, see here, right? E-commerce. I think we already discussed some of these projects already. Identifying consumers who have a more buying pattern, who are more buying, so that we can personalize the benefits. identifying consumers who are very loyal or who are doing regular, who have a regular buying pattern. So probably we have to give a personalized offers. I think a lot of these things are already happening in the current e-commerce applications, right? So personalized benefits, right? They have been personalized. A lot of these bonuses, a lot of these benefits have been personalized. Personalized. Recommending products, which is when you are buying a certain product, so based on your pattern or based on the type of products you are buying, so we try to the applications uh, try to recommend similar products. This also we already seen in Amazon, Facebook, Flipkart. There's a lot of these things, right? So you can see when you are buying a product, it automatically recommend similar products. It's also based on AI. It's also based on AI model. So the model will understand the type of products you are buying, right? It will understand those attributes, and the model is built. So it will be fed to that model, and the model will be able to predict what are the similar products that we can recommend for a customer. Analyzing reviews. So this we already discussed for a given product, right? Suppose you take in mobile, right? We need to understand. So we need to from the reviews, we need to understand whether the product is doing good or bad, whether it's doing good, better, average. Based on the rating, we should be able to, and whether we are getting positive feedbacks or negative feedback, right? And what kind of features we need to add. So those lot of these things nowadays we people means the organizations are able to decide. Okay, many of these features, so they're able to add based on the reviews, right? Because people will list the drawbacks, people will list the problems or issues, right? So that will automatically get mapped to the features. So next, what is this? Potential. Okay, manufacturing. So manufacturing industry, we are having potential monitoring systems. So this I think we'll go into detail into in the further slides. Each of these, some of these projects I think we'll try to see in brief what it does. Okay, manufacturing industry has a lot of these projects. Okay, maintenance scheduling, anomaly detection, and in banking, we do fraud detection. Fraud meaning whether the fraud has happened or not. Okay, depending on our transaction, whether a fraud has happened or not, and then credit risk modeling. So depending on our transactions, or depending on our history, and the credit score, so they want to tell us will be a defaulter or not. There will be a defaulter, whether loan can be given or not. Customer lifetime value, for which customers we can give benefits, for which customer can give more benefits based on the customer lifetime value. Customer lifetime value will be based on a lot of other attributes like lifetime of the customer in the bank, right? How many transactions he's doing, what is the investments he has made, right? So a lot of this based on those attributes, and they'll come up with they'll predict the customer lifetime value, and based on that threshold, they'll try to give appropriate benefits, right? If you have more customer lifetime value, then they'll give better benefits. If it's less than average, so depending on the threshold, they'll decide that. Healthcare, I think huge lot of projects are happening in healthcare, like medical image analysis, drug discovery, right? Drug discovery. What kind of drug has to be given? I think this is in molecular. This thing, I think. So depending on the molecules of this thing, or what kind of drug. And bioinformatics field also, virtual assistants. And this is also is a lot of breakthroughs happening here. Virtual assistant, right? Where they'll try to. So you instead of asking a doctor, you'll ask a virtual assistant, and he will actually suggest or diagnose, right? Depending on the information which is available, patient's history, right? All of these things. Then we have transport. I think we already discussed this: self-driving cars, enhanced driving experience, car monitoring system within the car. Like nowadays, also, right? A lot of already have been added in the car monitoring system, enhancing the safety of passengers, right? Uh, Safety of the passengers, telling that okay before giving when you are driving, I think it will give when you're taking reverse, right, it will give the camera is there. It will tell, okay, how far you are and how near the objects are there, and if you're traveling, I think. So a lot of these things are built, okay, and a lot of innovations happening in transport industry also with respect to transportation and finance. I think customer segmentation. Segmentation is to segment the customer, telling that based on his buying pattern, meaning what kind of products you can purchase. So you can predict what kind of uh, products you can purchase, right? Types of products you can purchase. Types of products customer can purchase. Customer segmentation. Purchase in the sense in terms of insurance or uh, in terms of bonds or in terms of mutual funds, right? What kind of products you can purchase based on the customer attributes. Strategic decision making. So this is again for the banks or the financial organizations, right? So to make the decision, to make whether to invest in, whether they are to increase the portfolio depending on based on the different attributes, right? To make decision, I think they use this algorithmic trading. This is anyway most common, right? This is stocks. A lot of innovations are happening there. Okay, what kind of trades there? A lot of AI has been involved here now. So what, which stock can do better based on some historical data? Will tell which shares can do better, which stocks can do better. Risk analytics. This also is there. Mechanical industry, I think that we did not cover there. Mechanical industry also has a lot of applications. That is what we are trying to indicate here. So biomechanical applications, robotic applications, control engineering applications, solid mechanics applications. What are the advantages of data center mechanical? Mechanics quickly increases value by mastering data service. So this is typical not only for mechanical engineers, for anyone who are there, right? So what is that? Okay, we can do. We need to gain knowledge and value so that we can demand. Okay, move to bigger organizations, decision making skills, right? These are a couple of suggestions. What would happen if you increase the knowledge of data science? What will happen, right? That is what we are trying to tell. Analysis and results. Okay, programming languages to develop scalable. I think it's again subjective. It is applicable in generic. It's not okay. Everyone has to do this. Okay, you can suggestive ideas, suggestive approaches. Okay, it can be applicable to any other engineer, not specific to mechanical industry. But I think these applications are specific to mechanical industry. Data science in banking and finance. I think that we discussed risk modeling, fraud detection, customer lifetime value, customer segmentation, recommendation engines, real right? Fraud detection, fraud, and this loan should be granted. See, suppose we take an example of typically, I think use case is like okay. Loan defaulter, right? Loan. Or so this is typical application or typical data science project with happens in banking. Whether we have to grant or reject a loan for a customer. So for that, what we will consider most of the attributes. A typical example I will give. So there will be like, so first they will consider salary, one of the attributes. then gender, okay, gender, experience, experience, age, okay, age. Okay. So these are the typical attributes that they consider, and based on that, the uh, the output will be either yes or no, whether to grant loan or no. It will be like this. So what should happen here is, see, when you are working on this, you should be very careful. This whatever you give yes or no, right? Yes or no. So now once you have built a model and now given any new customer, suppose you have a customer, new customer, okay, and we take all these attributes of the new customer and we predict whether we need to give loan or not, okay, and we like this, we take n customers and we predict whether we give loan or not. So this also should be the model we built here, right? It should not be biased in the sense it should not gender biased also. It should not be gender biased or salary biased or experience biased. See, gender biased in the sense we should not out of that n customers, suppose 1,000 customers are there. Out of 1,000 customers, it is giving loan to 800 male customers and only to 200 female customers, right? Then this model is biased. So this also, the model also should not be biased. So this is so there should be balance. Okay, see, this output also should not be biased. See, that is what, when you are building a model, so a lot of considerations will happen. Okay, because when we are building, so, and experience. Suppose if there is more experience, then we are giving the loan. So it should not be based on that. It should be cumulative of everything. Okay, it should be cumulative of this, and this. Should be cumulative of all the features. And okay, so, and however the bank treats, right? Whenever when a bank is, see, many times what happens, right? We take the historical data of bank and we build a model. We take the historical data of the bank and build a model. And in that model, we find that the data is biased. So we have seen that, okay, we build a model using the historical data of the bank, and then we see that, okay, bank is giving loan to more to female males and than to female. Then it is biased. Then I think those kind of insights also will come out from the historical data. So whenever we build a model, we should make sure that, okay, lot of other characteristics have to be kept in mind. One is the data should be balanced. Whatever feeding we are feeding in data, it should be balanced. It should not be biased. And the result, the predictions what we make also should be very careful that it should not be biased. So that's very important. Data is in agriculture. So this we discuss, right? In agriculture also is a very important field nowadays. Okay, and a lot of innovations are happening in agriculture field also. Okay, so I think some of many projects are happening there, but typical projects which we come across or which we have seen, right? Those is what is listed here. So a lot of other projects are there, but these are the typical projects which we have seen. What is this? Digital soil and crop mapping. So which crop has to be grown in which type of soil. So we have the field, right? The field. So farmers generally they have made some analysis for growing the crops. So different types of crops. But now based on the AI, depending on which is near to water bed, which gets more sunlight, or which is based on the area and the location, then they are going to map which crop has to be grown in which area. Weather prediction, I think this is important, right? This is also important. So based on the historical data, we should be able to tell whether this month or this week, at least to this week level, right? We should be able to tell whether this is anyway. See, it is still innovations is happening. Whether we will be able to tell what kind of temperature, whether we'll be able to get rain, sunlight, right? Sunlight and wind. What will be the wind power, right? So all these things we should be able to predict, and then based on that, especially for this vegetables, when you are growing vegetables, right? These are like short-term these are like they require very short period of time to grow these vegetables. In that case, this is very weather prediction plays a very important role. Very very important role. Okay. Just again HPL, yeah. Why is not unmuting? Yeah. Okay. And then fertilizers recommendations. What kind of fertilizers should be provided for what kind of vegetables or what kind of crops, right? This also we right now I think a lot of innovation is happening in terms of AI. Models have been built, so has been recommended. A lot of recommendations are happening on the fertilizers front. Okay, so here also they need to predict for which vegetables what fertilizer to be used, because when it is what happens, because of the more fertilizers also sometimes the crops or the vegetables may get bad, right? So those kind of things I think we are going to predict. It will be very difficult for the humans because uh, based on the experience I think they are still doing, but many times what happens, will they not be able to the accurate measurement, they'll not be able to tell how much fertilizers we have to put and where. So those kind of things I think AI is doing better now. Disease detection and pest management. Disease detection. So this disease detection, right? How do you detect whether the crops are diseased or not? Okay, right? So generally, what they do is they use a drone and take the pictures. Take the pictures of the crops of each section of the crop, right? They take the picture of the crop. So this will be the images of crops. Crops or vegetables. Images of. And that will be fed to data modeling. We do so image data. So you get to this in the images of the crop, right? From the images, so you take some 1,000 images of the entire field, right, of the crops, and from that images we should be able to tell whether it is disease is there, yes, if disease or no, should be able to tell. Similarly, DAG or CART, right? Diseased images will have some features which is not there in, which is not diseased. So the model will be trained according to that. If you have fed so many images, it will be able to understand given an image whether it is diseased or not. So it will be very useful. See, when you have a big field, so if this section of the crop is getting diseased, right? This we get yes for this, right? Immediately we can apply medicine for this or the fertilizer for this, and then we can retain. We should prevent the other crops also getting diseased. Otherwise, entire crop will get diseased, right? So this is disease detection. So it will be able to beforehand it will be able to detect the disease, and then we'll be able to manage the disease in a better way. Pest management. Pest also same thing. Okay, wherever we see, we take the pictures of the images of the crops and see whether it has been attacked by or it is been attacked by the pests. Right? If we are able to make out that, immediately we can control the pest. We can manage the pest. So that is also very difficult for the humans, where they have to go and check each and every plant every day. Every day they have to do it manually. They have to do it. Now what will happen? Drone automatically take the images of all these plants at one time. You can sit at one place, and the model will be able to tell which is pest, which plants or which crops need to be pest controlled. So that is how we think we'll be able to manage the pests, right? Adaptation to climate change. And this is again correlated to weather prediction. We predict the weather, and then depending on the weather or the climate, right? Climate, especially weather is mainly for short-term plants like vegetables. The climate change will be mainly for crops, kharif crops or uh, those crops, right? It will be based on the seasons and based on the climates. For that, based on the satellite images, based on the climate changes, right? We should be able to adapt the crops, which is very difficult for the farmers. Farmers, because nowadays, because of global warming, the climate changes. I think it has become difficult. Not like earlier, where the farmers were able to check the climate change and they are able to make the decisions. But now it has become difficult. So based on the satellite images and a lot of other attributes, they'll be able to predict the climate change, and based on that, they'll be able to adapt the crops. So this is also is very important happening in agricultural field. Automated irrigation system. Automated irrigation system. This anyway, I think how much water supply is there? What is the water bed? What amount of water? What is the level of water? And what crop can be grown based on the level of water, right? And we have sufficient supply of water to the canal, right? Whether based on the irrigation system, whether it gets filled this year or this season based on the prediction of climate or the weather. So and what amount of water will be supplied. So all those predictions will happen, and then based on that, we will be able to decide. The farmers will be able to decide what needs to be grown and how much needs to be grown. So this is also happening. Okay, so lot of applications are there existing in agriculture field. These are the typical or the predominant ones which are very popular, right? That is what we are listed here. But otherwise, lot of AI models have been built for lot of benefits, because they are many of these things are done manually, and it is actually it takes a lot of time for the farmers to predict or even to adapt, right? So those things are trying to do. Especially, I think it all started from Israel. I think Israel was the first city to do all these innovations across agriculture. Now I think it has been done in multiple places, multiple locations across the world. Okay, we'll take a quick break for some 5 minutes again, and we'll be back in 5 minutes. Okay, we'll continue. Hello. Yeah, welcome back. So I think there was a question like what is happening in the construction industry. I think very good question. I think see a lot of innovations are happening in data science construction industry also. It's not that okay we are not listed here. That's not mean it's not happening. See, I think one such use case which I have worked upon was like when you have a planning housing plans, right? Plans, and I think there are some data science applications which are built to identify faults in those plans, whether the doors they're missing the door, or they're missing some structures, or they're missing some outlines or whatever, right? So those kind of I think we have worked one for like for an Dubai project where they are giving a lot of these plans of houses, right? And I think they were structure means the images of the plans, right? Images, and we need to find whether there is any faults. That is one. And second one is object detection in those plans. Object detection in those plans in the sense, I think given an image, we should be able to detect which is the living room, which is the bedroom, which is the master bedroom, which is the balcony. So that is object detection. So that was and label them accordingly. So given a plan, so you should be able to segregate. You should be able to segregate each of these uh, components to different and label them accordingly. So that was I think one such project which we are working on. Likewise, I think there are a lot of things happening in any industry. That's why I told you, right? It's not limited to you name an industry and data science is happening there. That's why I think there's a lot of demand. And I think in one of the orientation, right, I even showed that okay, billions of jobs, right? Billions of jobs is what is expected in 2026 itself. That was the last year survey. I don't know what is the current. I think it may be more because data is limitless, and domain is not it is not restricted to any specific domain. It is also in covering all the domains of the industry, right? That's why I think even in education, I left up education industry. In education also, I think a lot of things, especially in education also. I think, but we now listed. I think we keep on listing. There is. I think we can't fit in one or two slides, right? There are a lot of. If we start listing all the domains, right? So, I think to answer the question, I think obviously yes, in construction domain also a lot of data science projects are happening. Data science in marketing. In marketing, I think many of you who are working in marketing, customer segmentation. So to identify the customers who can buy, who can purchase next set of products, what set of products they are going to purchase, so that we can market the products accordingly. Real time analytics. So what kind of demand and supply for the products is required? What products are required so much? I think that is very much happening now in the current as of today, right? I think what type of food is required in the next 1 hour, what type of products has to be there because see the products are getting sold in a matter of hours and minutes. I think any new products gets released. So based on that, we should be able to supply this demand and supply has to be planned accordingly. Next, predictive analytics for customers' behavior. Predictive analytics for customers' behavior. I think this is also important. So if you want to retain set of customers, customer churn, we call right, the customer churn prediction, meaning we have to we have to retain the customers based on the customer behavior. We need to know. Okay, I think many of us also, if we have already seen a lot of this. Lot of these retail applications will send an email to us telling that you have been inactive for so and so days. Okay, can you please log in once or whatever, right? I think these are the recommendations for you, right? Then these are like, okay, AI behaviors. I mean that they are trying to understand the behavior of the customer. And if you are buying more, I think they'll try to recommend, telling that, okay, this is what you can buy, and these are the benefits. I think I've seen customers who have a different buying pattern, or they have a different set of benefits compared to the customer who is having a very less buying pattern, right? Um, predictive analytics to qualify and prioritize list. Pattern, prioritize leads, right? Qualify and prioritize leads. That is something the products. If some customers are buying a set of products, right? I think I think we can't just judge based on one or two customers. There are millions of customers across the world who are buying such specific set of product, right? And only a model manually to analyze them will be very difficult. But if you give to a model, you can see the trends, and prioritize those products, right? And we can also see if some product is dipping, which is not doing good based on some feedback or whatever. Then we need to remove that product, or we should use that as a lead for improvising that product or whatever, right? We have to next version of it. They try to release the next version of the product. Predictive analytics to bring the right product to the market. So this is again based on the reviews feedback. So suppose many times what happens, uh, many times what happens, the version which has been released, the next version, suppose if you take a mobile, now they will release version 1, and the next version which is released, right, that will be not be so successful as version 1 because of the features that has been added to it. The features people may not like, they will get a negative feedback because that will not be the feature is not worth what people for their usage. So immediately many times we have seen that, okay, the next version of the product will be released earlier compared to the gap which had between release between version 1 and version 2. But version 3, within a matter of 6 months, they try to release to improvise the product or adding a feature which the customer may like, right? So that is happening nowadays, right? If you see in the mobile, especially in the mobile industry, right? Every 6 months, I think a new version of the product will be released, and sometimes it has to be scrapped. It has to be sometimes it has to be based on the feedback. It has to be either revamped or a next version of the mobile has to be released. So all these are happening at the back end with predictive analytics. The model has been built, and all these attributes or the feedback the customers have been fed in to the model, and based on the suggestions, right, from the model, I think a lot of these decisions of the products have been taken. Recommendation engines, which is the most common, right? I think all of us would have already come across this. If you are using a retail app or Prime Video or Netflix or a lot of these things, right? Netflix was the um, first this thing to come up with this recommendation engine. I think they had actually put up a challenge telling that, okay, what would be the best approach to recommend, right? Recommend the movies. Then I think during that time the algorithm was built where based on the attributes or based on the attributes of the customers, what movies they're seeing or what features or what kind of movies, then they started recommending the movies, right? So similarly, I think in now even in Google search or in Google in YouTube or in any retail apps like Amazon or Flipkart or Facebook, lot of these recommendations, even in Gmail, everywhere, right? In anything you take, a lot of these online applications that you take, lot of these recommendations are happening based on that. I think even in Google search, when you try to search, I think you try to give most rated search or whatever, right? Those kind of, I think it's still think one is okay. Recommendation is a common thing, but how best you can give the recommendation, right? How do we improvise the models to give recommendations? That is also we should think. The recommendation is there from long time, okay, till end. It's not like that. Lot of innovations are happening to improvise those recommendation engines, right? Obviously, that will also have put up the demand in data science, right? That is how we should think. Okay, it's not okay. Okay, these models are already there, and these algorithms are going to stay long. I think once you know all the algorithms and what next, I think everyone will know the algorithms and what next. No, I think they are trying to improvise those algorithms. How do we improvise the algorithms? Optimal campaign channels and content. Optimal campaign channels. When you are doing the campaigning, right, channels or content. So, especially in TV media, multimedia entertainment, right? So, which is the most viewers and what is the content? See, now this is like video streaming. What do you call handling the video models? See, we saw audio, right? Similarly, this video processing also is there. Video processing also is a very big thing. I think it's not listed in this slide. Video, there's a lot of innovation is happening in video to understand the gestures, to understand the emotions, right? Emotions in the video, to understand the content, what content a viewer is watching more. So and in the TV, right? So based on that, they are trying to optimal the campaign channels and the content. They are to optimal their content. They are seeing more news or more sports. I think they are able to understand the user behaviors based on the content and the channels they are watching. So based on that also, a lot of recommendations, a lot of changes are happening, and they are trying to build those content based on that also. Yeah. Let me check for any questions. Yeah. Data science in HR analytics. I think this is also a lot of these organizations, right? So many, I think, to my experience, a lot of organizations, many organizations, right, have built or built AI. I think in the organization which I was working, also, I think we built a couple of data science applications for HR analytics. So attrition to understand the attrition rate, right? To understand the attrition of the employees, right, in the company, the organization, and how can it be reduced further they are using AI models. Churn rate. So how to take the employees, how many number of employees you should take per year or per quarter, based on what criteria we need to take. So there are models built for it. Okay. Churn attributes of employees who have longer tenure. So we need to understand why a employee is staying long in a company. So what are the attributes? So what are the attributes? What are the features that what are the features that is making him to be stay long? So you have so you got the you collect the data of all the employees who are staying for long, and then we should be able to tell, okay, these are the features. Based on these features, employees are trying to stay long. So then for the existing employees, we have to give those benefits. They're trying to give those benefits. Reasons why employees are leaving. So this again, during the exit employees, people during the exit interviews, people will people will take the feedback. So based on those feedback, they are going to reason out. They are going to build a model, NLP, natural language processing models, and to identify the features why an employee is leaving, or what are the features that are good or bad at the for the organization, or how do we they improvise it based on those feedbacks there, or models have been built around that. Employee survey data. This is for adding the benefits, improvising the organization, or what is the loopholes, and how do we improvise it. I think a lot of these things are happening manually now. Okay, now also the survey data is manual, so employees to take the survey manually and give his inputs manually. But earlier, based on the survey feedback, whatever the survey input, the survey features, they used to do statistically, they used to analyze it. But now it's not like that. They go through the model and identify the insights. Insights like what is that? Okay, employees are finding it good and bad at the company, right? Onboarding experience, again, this is same way. I think, how do we improvise the onboarding experience instead of talking to each and every employee and understanding it and noting it down somewhere and feeding it into Excel or whatever, right? You you take the feedback, or you do the feedback form, and online you take the feedback of the employees, and then understand the pros and cons, or you understand the reasons, like what is good and what is bad, by building a model around it. Future forecasting of employee performance. So this is also, so based on some features, okay, based on his performance, based on his awards, based on the honors, based on his appraisal, a lot of these things, his rating and everything. There is, I think, you can build a model to predict whether how the employee can perform, whether he's not performing good and he may, I think he's trying to move out of the organization, or whether he's performing better and he may perform more better. We have to give benefits for him. So those kind of things are also being predicted. Application of data science in HR analytics, estimating future investments means how much to invest in a company, right? If based on the churn rate, attrition rate, and employees who are leaving, reason you are leaving, right? We should be able to estimate how much we need to invest in a company, invest in those areas, right? You can't. Earlier it was consistent based on the profits or whatever, but it's not like that. Now you are taking live data, real data, and see, okay, if the attrition rate is so within this threshold, then we have to invest so much. If we want to onboard so and so much based on this model, then we have to invest so much. Getting insights. I think we already discussed this. Okay, we'll get a lot of insights from all of these models. So this is all about data, data science life cycle in what we studied, right? We started with data, right? We started with data, and what is the background of data science, right? What is required? And we have data requirements. Then we add data processing steps. Then we understood science, data science life cycle, right? Data science life cycle. Then we add data science pipeline, right? Data science pipeline. Then we are now data science in different domains, industries, right? Data science in industry. Industry. Then examples, data science, use cases. Use cases in different industries. That is what we learned, right? Now with all this, now think this is about data science and machine learning algorithms. We even touched upon machine learning, deep learning algorithms, and data cleaning, data stuff, visualization, data cleaning, data acquisition, right? Data acquisition, and then we talked about visualizations, right? Visualization. We talked about visualization, communication, insights, right? Insights. So all this, I think we covered most of this. Now we'll add one more. I think in that one of the section was some computer science, and we spoke about the programming languages, right? R and Python. So let us try to touch base on that. Python. So Python is an interpretable language. And as many of you would have already worked up on this, right? Many of you would have worked up on this, and for many of you it may be new. I think anyway we are going to cover this in our curriculum from the basics. Okay, in the basics. So, and why Python, right? Why Python? It's easy to write. I think if you already used it compared to C, C++, Java, it is easy to write, easy to understand. It's the way I think the instruction set is built up, right, and the way it's programmed, we program it, it's easy to understand. It's object oriented. It's also important. So many times, what happens when you're building applications, people may expect that okay, we require an object oriented programming language. So Python is object oriented. So I think for real world, when we are trying to map program real world examples, right, object oriented is very important. Object oriented languages is very important. So Python supports object oriented programming. Robust standard libraries. Yes, it has been developed from past long years, right? And a lot of people are community contributed to this Python community, programming developer community, and it has been made. The libraries have been stabilized and they're robust, right? And a lot of standard libraries are available now. You name for any application in Python, right? At least for even transformation, data frameworks. If you take like okay for building the data science models, I think a lot of frameworks are there which are in Python, like okay, TensorFlow, Keras, PyTorch, Theano. So most of all these frameworks are available in Python language, and the applications conversion from Excel, CSV, Gateway, or text format to whatever, right? These transformations, those libraries are available. Web scrapers, beautifiers. So web APIs, REST APIs, lot of web APIs, especially web APIs. Lot of these things are available. Okay, in Python. You name this, and so it's easy to use. That's the important thing. It's available in other languages also, but it's easy to use. Supports various programming languages. So that's also important. So you can interface with different languages, any high level languages like C, C++, Java. I think it can be easily integrated. So it supports various programming languages. Support for right. So easier to program real world examples. And here supports programming level like C, Java. Supports for interactive mode, GUI, right? Interactive mode. GUI is available. GUI is available. So you can use a lot of IDs are available, like IDs like PyCharm, uh, PyCharm Spider, and a lot of even Eclipse also. Eclipse also you can use it. Eclipse also you can use it. A lot of IDs are available. Dynamically typed and type checking means like any other programming high level programming languages, right? When you're typing, I think type checking happens, syntax checking will happen, and all those things will happen here. Okay. Databases and GUI programming. It supports integration with databases. Okay, a lot of databases use MySQL, or SQL, or NoSQL. Okay, SQL, everything. Extensible. I think it is extensible. So Python 2.0, 3.0, 3.8, right? I think it's extensible. I think that feature is available in Python. Portable. Portable is from one environment, one platform to other platform. It's easily portable. You can easily port from Windows, from Linux, Ubuntu, anything, right? You can easily port that Python applications. Scalable. It's easily scalable if you want from 2.0 to, if you want to scale it to some other version, it's easily scalable. Or if you want to increase the features or you add more features, it's easily scalable. Okay, integrated. It's integrated with a lot of packages. You can automatically build an application. It's not a monolithic application. It's an integrated application. It is an integrated application. Automatic garbage collection. So you do not take care of memory allocation and reallocation. Automatically, garbage collection is done. File allocation, file reallocation, file opening, closing, right? Those kind of things are automatically, if there is any garbage collection, is automatically done. Free and open source is also very important. It's free and open source. And there is a lot of support from developer, Python developer. It's also important, right? Community support is also very important. Support from community. Open. So what is Python? Python, I think we already discussed this. It's a powerful open source, high level and popular programming language, right? Used for web development, scientific and mathematical application. Scientific web development, earlier when we started, right, it was typically came for web development earlier, but now we are using for data science applications. We are using for a lot of other applications, using for data science applications also. We are building data science applications also we are using. Data science applications. And then scientific and mathematical application. We have a lot of libraries like SciPy, scikit-learn, NumPy, math. So for doing a lot of mathematical and scientific application development. Provides excellent library support and has larger developer community. This we already discussed. Provides easy integration with web services and GUI-based desktop applications. This also we discussed. So it has a lot of GUI support also. So GUI packages are available, so which we can develop good GUIs. Used by most of the companies such as YouTube, Instagram, Pinterest. Okay? Extensively used in data science and in developing machine language learning projects that we speak here. So a lot of this TensorFlow, Keras, PyTorch, right? All these are built in Python. What is Python programming language? It's a general purpose integrated interactive object-oriented high-level programming language. So interpreted in the sense, what happens here is, so when you write a program, right? Try to write a program. Print name, right? So now, if it is a compiled language like C or C++, no, both of these statements will be compiled one after the other, and an exe will be generated. And when you after the compilation of both of these, then a common exe will be generated. When you run it, one by one gets executed. But when it's kind of interpreted language, it starts interpreting first line and runs that. It will not wait to interpret the second line. First it interprets the first line and runs it. So name equal to test. It will assign name and complete it. If there is the error here, it breaks here only. Then after completing this line, it will come to this line, interprets this line and execute this. It's not that, okay, compile both of these, and then you run this program. It's not like that. It will interpret line by line. So it will that's why it's called interpreted, general purpose interpreted interactive object-oriented high-level programming language. It is defined as object-oriented scripting language. Scripting mainly because earlier when it was came up, mainly for web-based applications, web development, it was built scripting. That is why I think it is written as it's called as a Python script. Still, it is not a Python script. It was built for making small scripts for application development. But now I think we are writing a lot of object-oriented programming. Okay, that blends the support for OOPS, object-oriented programming, with an overall orientation towards scripting. Okay, this is Python. R, right? See, many of you would have thinking like, why two languages, like Python and R? Why don't we just do all the operations in one programming language? It's not like that. Okay, R, there is a distinction between R and Python. Okay, what is R? R is complete statistical language. It's a statistical language. A lot of statistical operations, statistical analysis is best built. A lot of packages for statistical analysis built in R. Vast community similar to Python. I think this is not 200 plus library. I think Python also has. But the distinction here is these libraries are not common. These libraries are more for statistical analysis, not similar to Python. Python has more general purpose libraries. Learning is easy, similar like Python. It's also open source like Python. R connects with other languages like Python. Crash platform compatible. I think this is also like Python only. Crash platform compatible. Excellent graphic output. So here also these two things, right? 1 and 2. These two are very important. Okay. So these two things tells that okay, they are more specific. Why R is special compared to Python, and why R is distinct. R has more statistical packages. Okay, complete statistical languages. To do some statistical analysis, we use R because it's built around that. And excellent graphical outputs. The GUI support is there in Python also, but graphical output specifically for visualizations of statistical results. Right, that's the important thing for visualizing statistical results. So it has been built. R has been built around that. Visualization exists in Python also, but there is generic visualization for graphs, private bar charts. That is available in Python, but in here more relevance is given to statistical analysis plots. Okay, that's the difference between Python. Let's see here. Difference between stable will give better idea how they are different. Objective data analysis and statistical modeling, which we discuss here. Data science, web development, embedded systems, because this is faster. Embedded systems, though C is not faster as C, but still I think it's used in embedded systems because it's easier to understand, write, and then faster to interpret. So data analysis, data analysis. See, this is used by data analyst mainly. Okay, this is for development, so this will be for data scientist. Data scientists and data engineers. Consists of many easy to use packages, can easily perform matrix computation as well as optimization. So these things are not supported here. See, R does not work towards building a model, data science model, or building data science application. Or it is trying to build around statistical modeling, data analysis. It tries to build around data analysis. Many packages to. So this is around matrix computation. Why matrix computation? This matrix computation and optimization is required for data science application, data science modeling. Locally run programs. Generally, I think it's not integrated or it's not web development. It's locally run programs for analysis. Okay, programs integrated with web app for easy deployment. So this can be deployed across cloud or deployed across multiple platforms. Poses problem for handling large data set because this is built for around analysis. So if you have a large data set, you may come across a problem here. And handle any size of data set, large data set easily without any fault. That is the advantage in Python. Because the purpose is different. Data science is built for data science applications to process bigger data sets. But here it is for mainly for handling analysis, structural analysis. ID is RStudio, RGUI, UID is here, okay? But here we have Spider, IPython, Jupyter Notebook, PyCharm, Eclipse. Lot of IDs are here. Okay? Essential packages and library. Typical ggplot2, DI, DD, words, caret. And we will see this of usage of this. Here NumPy, Pandas, SciPy, I told already, right? SciPy, scikit-learn, TensorFlow, Keras, PyTorch, Matplotlib, or graphics, okay? Matplotlib. Lot of packages we use, okay? This is mainly for application, data science applications. So this is the difference. Means if somebody asks, right, why are we studying both, right? Each have their own pros and cons, and the purpose is different. That's important. Support from each of these languages is different. Purpose. One is for statistical analysis, one is for building the data science applications and optimizations. Okay, right. So that's why I think the community has developed packages, right, which are more towards statistical analysis in R. But here the packages are developed because the purpose is for developing the data sets applications. Hence, they're built around that. Different libraries we are going to use in Python. sklearn for a lot of these mathematical scientific operations, right? sklearn and NumPy, sklearn. This is for mathematical operations, matrix. We'll learn in detail of NumPy, and Seaborn also will run. This is for visualizations. Matplotlib for graphics. This is for the visualizations. This is more higher versions of higher level visualizations compared to Matplotlib. Okay. Pandas. It's for data frames. Again for data series. TensorFlow. This is framework, machine learning or deep learning framework. This is framework. Okay. Keras, this is also framework. sklearn, okay, this is for applications, okay. Image processing and data processing models, data processing, everything is available. This is sklearn as machine learning also, machine learning algorithms are pre-built in sklearn, machine learning algorithms. R, so a lot of these R packages, they are all for mainly for statistical analysis. All these packages are built around it. Reshape, stringor, plotply, gplot, all is for plotting graphs, different plots for different purposes that we will see. Okay. So we'll be studying about statistics. Okay. And I think we should understand the background why we should use statistics, right? Okay. So till any questions till this time we have 12 minutes left. So before we wind off, any questions so far? We'll try to use these 10 minutes for question and answers if there are any questions. The questions based on what we have studied today or anything about future curriculum or anything around that. So let's start with this and continue on this next tomorrow also. So importance of statistics in daily life, right? Weather forecasting. We see the news like every day there'll be weather forecasting. So have we ever thought how do we get those information, right? So I think we discussed this. They are computer models built on statistical concepts. These computer models compare prior weather with the current weather and predict future weather. Meaning, what they are trying to do here is, so you have data of for 10 years or 20 years, right? So based on data, historical data, if this is the pattern for 1 week, so what was the next week pattern? Like 1 year back, 2 years back, 3 years back, right? So this is the pattern 1 week in the month of August. Okay, last week of August, I think in 2020, if last week of August, this was the pattern, then what was the next week pattern? Similarly, 2019, 18, 17. So they have 10 to 20 years of data, and based on that, they'll be able to analyze and tell predict the weather. So that's why. So statistics is important, statistical concepts. Statistics mostly used by researchers. They use their statistical skills to collect relevant data, otherwise it may result in loss of money, time, and data. Means if you are not collecting relevant data, statistics is used to collect relevant data. If you don't have relevant, if you try to collect all the data, right, then maintaining the data, using the data, everything, right, it's loss of money, time, and data. Okay. What do you understand by insurance? Everybody has some kind of insurance, whether it's medical, home, or any other. Based on the individual application, some businesses use statistical model to risks of giving insurance. This, I think, if you have this, I think this example, I think we will work one of the example in our statistics uh, session. So whenever you are providing insurance to any customer, right, an insurance agent, he considers a lot of features or attributes of the person. So for each person, it is different. The person's what do you call the behavior or his own assets, or it can and his goals, right? His personal goals or his background, family background, financial background, everything will be different. Based on that, insurance agent will use some statistics to provide what will be the best insurance for him, right? This anyway we are seeing, right? Even today, I think whenever we are to invest in stocks and shares, right? I think we need to understand. We need to understand. We need to understand. You will use a lot of application to predict what would be what is the historical trend, whether it will do better in future or not. We'll try to understand from the historical trend and try to see, okay, this stocks is going to do better or not. So there also statistics is used. So whenever we are prescribing some drugs, right? So sometimes it may be required to tell why these drugs are being used, right? See, every company, medical, also there's a lot of competition, right? In pharmacy, a lot of companies will manufacture these drugs, but which company drugs to use and why we are using it, right? There should be some statistical analysis to tell why we are using this particular drug, right? There are also statistics. So this is very important. Last one, right? We should see. I think many times will not be able to in a manufacturing company, right? Will not be. Or suppose you take a Coca-Cola company. I think when you are releasing the Coca-Cola bottles, right, or cans. So millions of bottles or cans are manufactured every day across the world. Or in a company, if you take in an organization, Coca-Cola company, in a manufacturing company, thousands or lakhs of bottles are being manufactured. So it's not possible to test. So many times, right? Quality check will be done, but if you want to before giving it to production or giving it to deployment or this, right? Then we have to do a sanity check. So which how many such cans has to be checked to tell, okay, the the entire set of product is doing good or the quality is good, right? That will be based on some statistical measure, right? It will be based on some So what proportion of cans has to be checked, sanity checked to tell okay the quality of the items is good. We can't check millions of cans, right? Each and every can, or it is of same size or no, no, no. You should take a sample. You should take a proportion or sample of this entire production, and then we should be able to do a sanity check. What proportion of this thing we should be picking, right? And how do we statistically prove that okay, if this set of sample are good, the entire quality of the products are good, right? That is basically statistics. Business, investments and portfolio management. I think wow, when to invest in what, and whether your portfolio is supporting 360-degree support, whether you have a 360-degree portfolio. So all those things are based on statistics. Okay, so many of these are still using traditional statistical methods. And why? Because if you're trying to build a model around it, right, it may not be maintaining that model and building that model may not have sufficient data. Sufficient data. I think traditional statistics will still hold good there. Okay, performance, market analysis, consumer research, marketing. I think this we studied. Market and demographic analysis. Use statistics to improve the quality of products manufactured. Statistics. When we study statistics, right? I think what is the background or what is the typical mathematical uh, background that is required? Linear algebra, probability theory and statistics, multivariate calculus. This is for data science, complete data science, right? What is the proportion of? See, overall, you should know the basics of mathematical statistical operation. That is one. Suppose that basics, whatever you should know, let us take that as 100%. 100. You need to know. Suppose it is only a small amount of this. You should know. Among that, whatever mathematics you need to know, what is the proportion of usage of these uh, um, topics, mathematical topics in data science? Linear algebra is like around 35%. Probability is like 25%. Multivariate calculus is 15%. Very less. Algorithms and complexity is 15%. Others is 10%. So I think if you know, then this is the proportion. I think just to give a glimpse of how much we'll be using, right? That's what we are trying to cover. So this gives a brief overview of what we are going to learn, right? In terms of data collection, data manipulation, data preparation, data acquisition, data model building, statistics, right? And what kind of technology we are going to work, and what kind of what kind of models we be building, and what kind of industry if you are working on, what kind of applications has been built today, and what are the statistics, why do you use statistics, and what are the mathematical operations we use. I think it gives a complete glimpse of what we are going to do. So tomorrow what we'll do is what kind of algorithms we are going to study, what types of algorithms, what are different types of algorithms, what do these algorithms do, right? And what is this NLP applications, what is image processing algorithms, if there are any. So those kind of things we'll learn tomorrow, so that it will give a complete picture or the perspective or the broader perspective of what we are going to learn in our future classes. We are going to get into details of each of these. Each session will talk on each 1 or 2 sessions will talk completely on Python or machine learning algorithms or data requirements, data analysis. But here we are covering what we are giving a broader perspective of what we are going to learn. I think with that we came to the end of today's session. So if there are any questions, please go ahead. Otherwise, we'll connect back tomorrow at the same time. Okay. Okay. Thank you. Thank you all. I think we can. I think let's disperse and then connect back tomorrow. If you have any questions, you can come back and we'll discuss tomorrow. If you have anything now, okay. Thank you all. Have a safe and good day.